Okay, hello, do you hear me? Hear me well? Okay, cool. So thanks very much, and yeah, welcome to my presentation, where I'm going to talk about like a few trade-offs that we take when building products that use a lot of data, that use machine learning models. Okay, just to get you some context about where we do it. So Allegro is the largest e-commerce platform in Poland. We have roughly 60 million active offers listed on the platform, and for the data volume, it's around the numbers you see. So almost 3 terabytes of daily data increment, and the Yarn cluster to handle that and all the processing of it. Okay, one disclaimer: it's just everything presented here is a common work of many people from our company. Okay, so then I'm talking about it in a few contexts that we use parts of the things that I'm going to present to build products like you see there, live products on our platform. So for search relevancies, suggestions, evaluation of those products, and those are typical use cases. And it's just the tech stack around, nothing very new or fancy. Okay, so first of all, I want to talk about one trade-off that we need to consider when building data pipelines, even jobs that process data, whether we work on it. It's more about how what's our process of working with it, whether we start and think from the real data, or we look at it from more engineering perspective and do it like it's done in any other software projects, which is usually test-driven. So what I mean by this, I mean like a data-driven approach would be to just straight right into the data you need to work on, and just experiment, work on it until you get an expected outcome. It's like maybe the most natural way for many people just to do like this. And by test-driven approach, I mean to gather some static probability sample of the data, get a test for it, specify the expected output, implement it, and only then, after we have it ready in like a really isolated environment, run it on production data. Of course, those are very extreme versions of those approaches. So we will come maybe to some, I think, in the middle in a while. So of course, it's with the data-driven approach, it's really easier to start. It's interactive, so it's easy for you to. You don't need to have a full idea in your head when starting, and you have a really short feedback loop when you do like this. But with test-driven approach, it's actually best practice because you are sure it works as expected afterwards. You have a safety, having a regression suit around, but it's actually harder to set up, especially at the beginning. It's hard to get everything around so that it really works as it should. Okay, so I should have put some fancy, funny image from the internet here. Why not both? Yeah. So if I could keep my notebook as a version control with a test suite around, run it on a schedule with some control around it, why not like this? And it's possible actually. We do it in a few projects. So we keep notebooks are actually kept in version control as a simple Python files. They are converted back to the notebook format and available always on some running Jupyter. And when you want to work on it, you can either go this way. So yeah, okay, it's just a project, so I can write a test, implement it in the IDE, push it to the version control, or I can actually look at the notebook itself and work with it in an interactive way. And only after that, I need to, like if I want to keep the testing coverage for for my change. I need to like go back one step after I know what I want to do and make it, put it in the source control. So it always goes back to the single point of truth, so which is the source control with Python files, and then it can go as well through the code review process, which is kind of hard if you just have, for example, keep some notebooks. It's not that easy. There is no good tooling around code review on Jupyter notebooks, or at least we don't know about. Yeah, so just one example of it, how do we test PySpark jobs? So as we heard on the previous talk, we as well use Docker here. We have an image with Python Spark that gives us a reproducible environment, and the kind of usually tests are like the end-to-end tests, like Marcel said. We as well, or at least I prefer them. They give you assurance that everything works, not just some small parts. So we typically mimic the storage as a file system, put some data, write a test to execute a job and verify that it actually did what we wanted to. Yeah, and it's run on our machine and on continuous integration as well. Okay, what are other building blocks? Well, to have it, your notebook must be parameterized, but providing a default values so that it can be both run on schedule with some specific parameters, but as well allow you to stay safe when working with it interactively. You need to run as a whole. It should be idempotent, meaning that if I run it twice or multiple times, the result is the same. We need version control tests with deployment. These are stuff that as well Marcel talked about a bit. What I want to highlight here is that it's actually, after we have some metrics, it's usually good to set up some monitoring around the process, even if it at least check the data set size, that you don't get an empty data set or really small data set when you didn't expect it, and stop the process maybe. Okay, another trade-off. I had recently an occasion to compare PySpark with like traditional Spark jobs written in Scala, and it's actually hard to tell which one is better. It depends, as usual. For sure, if you write it in Scala, you have better IDE support. It will fit if you expect the project to be complex. So if you expect to do a lot of engineering work, then you have refactoring ready, etc. And you have at least some level of type safety, for sure, everywhere in the like classic Scala code, but as well with using the new API of datasets, which is almost always type safe with regard to the data, column that you process. The almost, I will maybe show you in a moment what I mean about that. But in PySpark is for sure easier for non-developers to grasp, and sometimes it makes job like more concise. The data frame API is easier to mutate on it, add drop columns, which is not that simple if you go with the Scala version. So one example is the join story. The code from the top is a Scala snippet from one of our jobs, and you see it's quite interesting. Those _1 are a way to handle how join with is implemented in Scala Spark. And because it gives you like a structure of a structure of a structure. And as you can see, the names of the columns, types of the columns are not actually type checked, yeah, just strings. You see what will happen. The last part after the map is just to get the structure back to the flat data set format. While in a data frame API, for example, in Python, on the bottom, you would just get it's more streamlined. You would get a flat data frame after that. Okay, so this was like the first part of my talk. In a second, I would like to talk about how we put all this up into a schedule into a manageable system that works every day, every hour. And here I want to talk about Apache Airflow in some more detail. We use it quite extensively in Allegro right now. So this is a workflow scheduler. It can execute your process that you define at your schedule, and it will handle dependencies. It will handle quite a lot of things, and everything is specified, which is really great as a Python code. It's actually Python DSL, where you specify what should be done after what and actually everything. So if you want to do any fancy logic, or you need to loop, you need to build 3 models, you just can write a loop there and you don't have any problem with it. On the right you see a screen of one of the executions of the DAGs, and you can see this red thingy failed at that point. So the thing to the right is actually yellow or an orange. It means that, oh, actually I couldn't run it because it has missing dependencies. So it really makes managing and understanding what happened quite easy. What we have there in Airflow, we have operators, which mean do something. It's typically from the simplest as bash operator, where you can put anything, to operators handling HDFS, handling Hive queries, handling quite a lot of things. We have sensors that we can write our ETL so that it waits for something. Maybe wait for some data that is an input to your next step. Maybe ask some system about something and wait for it. We can provide variables at runtime to configure like you're running jobs. We have pools, which is something that you can ensure that there are not more than n processes pushes, for example, data to your database, because it would crash. But you want to run them you don't want to put them sequentially because, for example, they have different dependencies. You have branching logic, and there is a lot of integrations with Hadoop ecosystem, with Amazon, with various databases, like available in the Airflow itself, apart from what you can write there. Execution control, it gives you errors monitoring. You can get notified when something failed. Of course, it can retry a thing before it says it's an error. You can specify timeout so that some process will not hang for more than 1 hour. It will just fail after the time if it didn't finish successfully. You can investigate the duration of your tasks in time, for example, to see if they do not grow. It may be a bad sign. Okay, nothing comes without a price to pay. It's actually a free and open source system. It's really good, but it has its quirks, I would call it. And that's why there are at least some resources that specify those pitfalls. So if you are to try with it, just read those even before you read the whole documentation, because it may save you just one day or a few head scratches. It's quite mature, although it's used by more than 100 companies, as I looked at the GitHub. So we use it at least in a few projects here. And maintaining it is actually quite easy, but I understand that for teams that, for example, don't want to focus on technical stuff at all, like not having any engineering perspective, it would be even easier not maintain it at all. That's why we are exploring internally an Airflow as a service, where each team would be able to just click itself and set up a new Airflow instance. That's actually because Airflow cannot be used as having a multi-tenancy support, so you cannot use it. You cannot use one instance by different teams that are not sharing their code. And there's quite a neat idea that we didn't explore fully, that it's a DSL, but you can build your own DSL on top of it. So if you have some company-specific things or project-specific tools, services, you can have someone to like write dedicated operator census for it, and every team will just use those building blocks just to write, like on a higher abstraction level, write their definitions of their jobs. The tags, I think I didn't explain it. It's just the whole graph of execution. It's called direct acyclic graph. Yes, so I guess it's quite powerful. Okay, some alternatives. Well, actually, you can get cron, which is just basic scheduling, nothing else. There's Uzi, which is part of some distributions already, so it's hard to do something more complex with it. It's hard to maintain because either you click in the GUI everything, and then it's lost if it crashes, or you don't have any versioning, or you use an XML, which is not very nice. Stuff like that. And there's Luigi, which is the most similar to Airflow, but it doesn't have a scheduler built in. It's quite slow. It's slower than Airflow for large graphs of dependencies. It doesn't have that many features. Not going into every detail. They are a bit different in a way that how they handle dependencies. So Luigi is more like output oriented, which means that it expects every task to produce some state that can be checked, for example, a file somewhere, and it then checks if this file is ready, while Airflow is just using its own database to know which task was already executed, which task failed, etc., etc. So, yeah, but there are alternatives. Okay, and I guess that's it. It took really, I didn't use the whole half an hour, so I guess I'm more open to questions if you want. Allegro is hiring if you like building such things. We are looking for data scientists, software engineers, so you can.
We have time for questions. So
okay.
Starting with the first one from the back.
Because you were talking about the Jupyter notebook in the beginning and some of the functionalities you like added to it. Have you considered using Zeppelin notebooks? And if yes, if you did some comparison for your needs?
We tried Zeppelin, but it was quite a long time ago. I didn't do any comparison recently. We've heard it's used, and a few people prefer it because it's not like a gold standard in the whole company. But unfortunately, I cannot give you my personal comparison.
Next one on the back. Guy from the back was first, so.
So do you think it's easy to pick up for a team of data scientists only, or do you think they would probably need some engineers to set it up for them as well?
You mean to set up an Airflow instance? Yeah. I think it's possible if at least someone already is doing some hacking with bash scripts or with some system integration. Then it's doable. It's getting really stabler and stabler with each version. It used to be not a thing that I would recommend, but right now I think it's doable. Maybe with some very small support at the beginning.
My question is Airflow related. So do you have any failover strategy, like a cluster of Airflow instances? If one fails, another one can pick up the job?
Yeah, well, in the scenario where we're going to have it like an Airflow as a service, then it will be deployed in an isolated way in Docker container on Mesos. Then it will be quite easy to do it because we can just scale it up and it integrates through the database, which then will be just a single point of failure probably. I'm not sure if there is like the yes, but currently we just use it in a few places, just on one machine. If you have some monitoring that works as this, that if the effects of jobs are not there somewhere and you get notified, you can catch that up, yes, because you cannot monitor airflow from inside airflow in this scenario. But we actually never happened we never happened to have it like down because of the machine. But yes, having it in a high availability would be the way to go if you need it.
Okay, one more. All right, so thank you so much for your talk.
Okay, thank you.